Okay, Amy, tell me about your research.
Okay, so this is a poster that I made for a conference last year, so it's not quite up to date, but it still gives you a general idea about what I'm doing. So my main project is using an atomic force microscope, which is I've made a diagram here. So what happens is you have your sample and you have a very small cantilever that's like 20 microns long. You shine a laser onto the back and then you can track the bending of the cantilever. So this allows you to measure the force, the interaction between your AFM tip and your sample. So if you draw your tip across your sample, you can build up an image sort of by scanning along X and doing it a number of times. And that's what we have here. So these are images taken in air of Leishmania parasites. So these are parasites that cause cutaneous skin disease in this case, but it's sort of stigmatizing. They self-heal in sort of about several months up to a year. So
Hmm.
it's a real sort of problem disease, and some forms of the disease actually can be fatal as well if you have a visceral infection. So my basic technique to get the images, that's fine, but what we want to do is look at it under liquid and look at it with a specific molecule on the tip. So we've I'm now attaching my parasites to the surface using a positively charged surface because they're negatively charged due
Hmm.
to the molecules on their surface. And my cantilever, I'm covering with polymethacrylic acid and then some sugar molecules. So if you look at this figure here, if this is the substrate, which is the AFM tip, we have this backbone, which is the polymethacrylic acid, and then we have these big chunky molecules, which are the sugars that I've attached to the backbone. And this just is sort of some of the characterization we've done to show that we have actually coated our tips. Um, the process itself is kind of demonstrated here. So we're looking for a specific interaction between this sugar binding receptor and a big sugar molecule. So the idea is that if you have a molecule that is involved in a specific interaction, you should have a higher force readout than you should if it's not involved. So we're looking at different sugars in this case because sugars are believed to be involved in the interaction. And instead of imaging, we're staying at the same position in X and Y, approaching the surface and retracting, and
Hmm.
actually taking a force curve. And then by doing that, you can build up a sort of 32 by 32 pixelated part. So you could have this parasite, and then you might find that the forces vary along the parasite. So it's looking for area-specific adhesion forces, and particularly looking at specific adhesion
Hmm.
using these different molecules.
So if you know the adhesion forces, you can begin to figure out how to sort of get in there and interact with the parasite and stop it
Yeah.
from.
So if you can block these sites, these sugars, we're looking at the stage of the parasite that's in the sandfly, which is the host that takes it between humans. So these sugars are potentially involved in the binding of the parasite to the gut, which means that it's not defecated with the blood meal, so it can be regurgitated into the next host, which would be a human. If you can stop them attaching to the gut,
Mhm.
they'd just be defecated with the blood meal, and you wouldn't get transmission.
Excellent.
So.
Good work.